This content talk focuses on representation in project work. Specifically, what this content talk is designed to do is to help educators think divergently about what it really means to represent ideas. Young children have a variety of instincts that are natural to the young child. Dewey describes these as the nature of young children in terms of impulses or instincts that drive their learning. There's the social instinct in which the children are driven to have communication and language with others. There's the instinct of making, which is that constructive impulse. Dewey, along with Vygotsky, found that play was an important way that children would represent their thoughts and ideas using expressive play, movement, and gestures. Children often create play environments such as post offices, stores, while they're studying, while they're elaborating on the ideas. They also often build constructions or large size models. And so we can think about how to support this type of representation with the kinds of materials and environment that we set up. Dewey also said that children have an instinct to investigate. Their natural curiosity drives this instinct. It is an instinct to investigate that grows out of a combination of constructive impulse with the social instinct as well. The young child doesn't have a lot of interest for abstract inquiry, as Dewey points out. However, the children want to examine the real artifact, take it apart, investigate it, and go through the process of what the real life work is. For example, in the camera project that we read about from the Green Book, Laura Taylor's camera project, during the field site visit, the children collected and experienced different information, and then afterwards they wanted to make a dark room in their dramatic play area so that they could pretend to develop photos that they had seen in their field site visit. This is an example of how the children were wanting to further express and also investigate what they were learning about. This led to them thinking about the correct sequence of the chemical and the developmental process of those photos. And so we can see this in many, many other types of project work as well. The last instinct that Dewey talks about is the expressive impulse. Dewey describes this expressive impulse as the art instinct. He says the art instinct is connected mainly to the social instinct, the desire to tell and represent. And we like to say in project work, we're representing. Children are taking in what their environment, what their teachers, what their experiences with other peers and experts, and they like to take that project work and put that out in multiple ways. In understanding for design and in UDL practices, we think about how children have multiple ways to represent, whether they're telling, whether they're storytelling, whether they're painting, drawing, sketching, sculpting, molding from objects or molding from constructive blocks. And the children are telling the story of their process while they're also building that construction. So that kind of gives us an overview for what we can be thinking about of how and why representation in project work is so important. It's also a time frame where I just explicitly tell teachers, this is where we are moving from, this is not crafts. This is not the teacher draws the flower and the grass and the sun and shows the children a model and they are imitating that model. This is where children are making decisions. They're making a plan. They're thinking ahead about what they want to sketch, what they want to draw, what they want to build, what they want to create in order to represent their ideas as they are learning and then also as they culminate their learning. So how do young children render their ideas? First, you might want to think about that word render. If you refresh your memory by reading chapter 6 and becoming young thinkers, you will get a little bit of a more sense about what that rendering can entail and what rendering means. Rendering can mean many different things. For the purposes of this talk, we're going to think about how rendering means to represent or depict artistically. It's important as we think about how children are developing their art instinct that it is more about the process that they go through to render and think about how to put their thoughts and ideas into symbolic form, rather than, as we would a true artist, think about the product. Representation is defined as a creation that is a visible, tangible rendering of someone or something. Render is to pre-produce or represent by artistic or verbal means. For young children, this also includes dramatic play. In project work, representation is the rendering of ideas or concepts that are learned in project work. The rendering of ideas or concepts requires important areas of the brain. Recall from an earlier content talk about why we do project work. We are getting the whole brain involved in learning, which is what actually makes the learning occur. Concrete experiences come into the sensory and post-sensory lobes, and in those regions, those concrete experiences provide the opportunity then for reflective observation in the temporal integrative cortex. This is where the learner is saying, what does this information mean to me? How have I seen this information used before? What do I know about this information? And then that's where that information moves to the frontal integrative cortex, our frontal lobe. That's where executive functioning takes place, where children and learners can begin to make decisions, they can plan, they can create, and then they act on this thinking. Oftentimes, an abstract hypothesis is formed in our mind as we're thinking reflectively about those concrete experiences. Learning occurs when the premotor and motor cortex are able to engage the learner in actively testing out this information. If children are learning passively, if they're answering questions, doing fill-in-the-blank informational sheets that a teacher gives, that's passive learning. Rather than if children are asking their own questions and seeking out different ways to experience, investigate, do, think, learn, actively test out after they've predicted what they think will happen, this helps concepts to be learned become more strongly profound in the brain, and then the rendering of these concepts learned will use all of the brain components. So again, that concrete experience moves from the temporal integrative cortex to those executive functioning areas where planning occurs, hypothesis form, plans are created, and then we test those out. Begin at the back of your head where that sensory information comes in. You hear it, you see it, you feel it. These concrete experiences stimulate your senses. The younger child, so the younger the child, the more concrete experiences are necessary. This is why there is such a focus on real artifacts, and Judy will recommend, as you've read in Young Investigators in the Green Book, you need to bring in 25 different types of artifacts. So if you're doing a project that maybe is focused on a specific pet or animal that's a domesticated or wild natural animal in Missouri, you might bring in the real items, whether they're containers of their food or care items. You might bring in real photographs. You also might be bringing in materials that are used to form their kennel, their compartments, their tools that are equipment that is used to care for and house the animal. Those are examples of how we would bring in some concrete objects. Then the concrete experiences is needed because we're trying to get the child's consciousness stimulated, right? So when we think about, we're building the mental tools of the mind, as Vygotsky details, and Judy has a little bit of that written in Becoming Young Thinkers early in chapter 2. You can read about how we're helping through these concrete experiences form the mental tools of the mind. Information coming in is integrated with previous experiences in the temporal integrative cortex, where it is reflected upon. An example is when we're sitting on a park bench after it rains and you first sit down and you notice nothing, but then gradually you're getting a message from your senses that your pants are feeling different. You reflect on your previous experiences and observations with rain and realize the park bench is wet and you are sitting on the rainy part. So then the front section of the frontal integrative cortex is where you're thinking. It's the executive function. So behavioral control, focus, the ability to have higher level thinking, such as problem solving, hypothesizing, synthesizing, evaluating. So in our rainy bench story, the brain may analyze, what does this mean? I have wet pants. The wetness is soaked through my pants. Oh, now it's soaking through to my underwear. I wonder how much water is on this bench. I wonder if I will have wet splotches on my pants when I stand up. I think I better stand up and get off this bench before I get any wetter. These are the things that your brain would be thinking. And then at the top of the brain, that motor band that goes across the top of the brain, so from ear to ear, if you put your fingers above that, we often call that the Tiara Moment, when we're actually putting our thinking out and acting on it. So in our rainy bench story, you would think, okay, legs, lift me off of this bench and do it now. So the motor band is also where drawing, writing, painting, dancing, singing, talking, acting, role-playing, constructing would all be directed. This is very important because we know that actually doing something about what we are learning, about what we are thinking, about what we are discussing, about what we are experiencing, doing something makes more neural connections, helps us remember, and builds a network of neurons to make a strong foundation for learning. We all know that if we memorize something and say it out loud, we'll remember it. If we write it down and illustrate it, though, we will remember it even more. If we create a presentation and we have to give it to others, we really learn it even more. Putting it out is as important as building a robust brain network. At the conclusion of this idea is use it or lose it. This applies for anyone from early ages to an old age. If we're not having experiences through a concrete experience, reflecting on that, understanding and connecting it to what do we already know, if we're not thinking abstractly, having time to make a plan, hypothesize about this information, and then test it out or represent it through all those different ways of knowing and representing, then we're going to lose it. I apologize, I scooted that slide ahead too quickly. If we don't have proper opportunities to represent, then we will lose that information. If we're just filling in a worksheet, if we're just completing work, if children are memorizing and moving on to the next isolated skill and are not integrating their concepts together, then that representation is not strong and it's really not in their long-term memory. So how can teachers support representation of ideas and concepts in learned project work? In Becoming Young Thinkers in the Burgundy book, right in the center of the book is the chapter 6 on representing thought. This is an important chapter that should challenge your thinking and move away from how teachers have done representation. The little paper plate spider found on page 85, could be found in my classroom as a kindergarten teacher 24 years ago. What I learned early on, however, is that those representations were crafts. I spent more time assembling the table of all of the different materials, like the googly eyes, the paper plates, and cutting out all of those pieces of construction paper. I spent more time than the children did in assembling it and mimicking my representation of a spider. And truly, this paper plate spider, as the figure 6.1 says on page 85, this paper plate spider has little similarity to a real spider. It doesn't provoke thought, and it doesn't teach anything that's real about spiders except for misconceptions. Spiders don't have two eyes. Spider legs and bodies have a specific way for those legs to be attached. So how can teachers support? Here are those representations that show misconceptions of spiders. This is what some of us have thought that art should be in preschool and kindergarten and first grade in the early years. These are really just simply teacher-led activities. The teacher thought about this. It's directed by the teacher. They have a prescribed process. You must paint the paper plate black. You must use black legs. You must put on two eyes. We could say that it represents a spider. We can all assume it's a spider. However, what are the differences between a real spider and these representations? As I've mentioned previously, the way that spiders' legs fit on their body is different than what is represented here, as in one head. That is not where spider legs are. Spider legs have more than one pair of eyes. Actually, they have multiple pairs of eyes. Spiders are different colors. They're not white with black legs. They're not white with brown legs. They certainly don't have a smiley face, as seen here. And so we can see that we want to shift our thinking about representing what is real and moving away from art. And we also have to move away from saying, and this might hurt, well, but this is a good fine motor activity. I want everyone to think now that fine motor activities occur all the time throughout play, throughout manipulation of objects, throughout using different types of materials, throughout the child's daily routines. And so it is really only the children who have significant delays with fine motor skills that we need to be justifying activities for fine motor skills. They are going to develop fine motor skills, but the typically developing child will. And so we really want to challenge ourselves to move away from doing things for the sake of colors, shapes, fine motor skills. Children are going to learn those through really meaningful activities versus conducting activities such as these. All right, so Amber Forrest shared her spider project, and it's featured in Chapter 6 of Becoming Young Thinkers. So in contrast to the paper plate spiders, Amber's children, who were preschoolers, they conducted a project on spiders. So it's important that you have read that spider project. You can see how it started out. You know, there was an experience that happened where children became naturally curious about spiders in their life. It began when they discovered a daddy long leg on the playground. And the children were trying to figure out whether or not it was spiders. And Amber, as the children asked, what makes a spider? Amber knew that this would be a powerful topic because she had observed that all the children were engaged, they were motivated, and they could find these in their own backyard. And so that was very important. So as the children, now I'm going to show you the slides of their representations. I want you to keep in mind that these representations came at the end of a long-term project. Again, it's important to read through those long-term projects in Chapter 6 of Becoming Young Thinkers. Amber also was a skilled project teacher, which is why she's featured in this book. But so she knew the value of doing observational drawings. Observational drawings are different than memory drawings. Memory drawings is where children, without anything around them to look at in terms of a real object, they will just draw a picture. Think about what you know from children, what they will do. They will draw themselves as a stick figure. They will draw usually a mom, a dad, someone else in their family, maybe a sibling. Sometimes they draw their teacher. What do they put at the bottom? Usually grass, maybe a flower. Is this ringing a bell? What do they put at the top? Probably a sun, depending on where they're at in the stages of drawing, but that's a memory drawing. So when children do observational drawings, it's because they are carefully examining and noticing details in objects and capturing the phenomena of that object. Page 87 of your textbook shares information that once the children had an interaction with an expert who visited, his name was Mr. Mike, and Mr. Mike brought in a pet tarantula, the children were very excited, and it inspired many representations in observational sketches. So in an observational sketch, the child is going to practice and learn how to move their pencil very carefully and methodically. And of course, this takes time. When children do this for the first time, you're really coaching them. And as children gain experience with observational drawings, they will begin to practice this as a part of their learning, as long as teachers are giving them those experiences. In Amber's case, she continued to help the children study spiders outside on their playground, and she would bring books and other research materials that would be carried outside. She would bring clipboards of paper so that children could continue their observation drawings. She said that in this project they came very naturally, and that's probably because she was bringing the tools. Even though she hadn't really specifically taught children how to do an observation drawing, which is important to note that you actually have to teach children how to do some of these processes before they get into project work. And if you're doing this for the first time, you probably haven't been able to do that. So it's a perfect opportunity for them to observe something, for them to learn how to look at it, and for them to figure out how to put what they see on paper. So that's very important. If you haven't done your own observational drawing before, that's a way to consider how children will do it. At the end of the project, which went on for several weeks, the children had decided, whenever Amber asked them, what could they do to, she initiated a class discussion about how they might share with others what they've learned about spiders. And the children discussed how they wanted to make spiders and how everybody could make the different spiders they studied. And so that grew into having a spider museum. So in this slide, what you are seeing are two parts of the exhibit. So I want to read to you about Anderson, which is on the left, and then I will read to you about Jacobs, which is on the right in this slide. So Anderson, and you can follow along in your textbook, this representation representing thought, what I'm going to share right now is found on page 89, where the figure 6-7 describes all of the different photos of the children's model of a spider. So Anderson joined the class almost at the end of the spider project. So this helps us think about how to incorporate children into project work when they're joining almost at the end. He didn't have a lot of knowledge or experience with spiders. He knew they had a lot of legs, and he chose to have his spider on an alien ship. So that really is good background knowledge for why that representation looks like it did. He chose a lot of pipe cleaners to represent that spiders have a lot of legs, but that was the extent to what his knowledge of spiders was, and so that's very clearly represented. Jacob, which is on the right. Jacob spent his time away from the rest of his classmates. So during project work, he was kind of that onlooker or someone that was in solitary play. He worked on his project with little discussion from students or teachers. He remembered that some spiders had hair on them, and the yellow pieces are the spider's hair. So this is a child who is experiencing their instinct is greater probably for getting in and learning how to construct with the different materials. He's not utilizing that expressive instinct, yet the teacher is supporting. I can see that, having been working with preschoolers now for quite a long time, and many of you can attest to this, he was really focused on how to use that tape, right? How to use the materials, of course, rather than that product, that model. But he did remember that spiders have hair, and so he found some representative tools to help represent the hair on the spider. Now let's look at a couple more of Amber's children's examples. We can see some more sophisticated examples on this slide. So Brolin's is on the left. Brolin had a baby spider with a parachute web. That is what this is. Brolin was very impressed that baby spiders left their place of birth by flying. They create their own parachutes out of the web to catch the wind. Brolin wanted his parachute to really work, so he found that yarn wouldn't work, and he had to try to have something catch the air, and so he decided on a paper plate. So notice this is a little more sophisticated, and even the fact that the legs represent the correct number, they're coming off of the abdomen of the spider rather than the head like our paper plate spider does. And he focused in on one aspect, a unique aspect of something that he learned. The model on the right that you see there, that three-dimensional, that was actually a pair of children that decided to work together, Luke and Josie. So Luke and Josie were the only two children who chose to do a spider together. They created this paper mache spider. They divided the work between them. One made the head, the other made the body, and they disagreed on the color of the legs at first, but then decided how to make them on each different side. So the children are putting their personalities into that, and you notice that there's even a few more extra components of a real spider on their model. Behind their model, actually, their plans. So Josie and Luke and all the children would first sketch out, plan, think, what were they going to make, how were they going to do it. So anytime that we can have children planning what their representations are going to be, that just strengthens their thinking. Here are, again, two other models. Again, more sophisticated as we go. So different children are taking in different aspects of the project. Drew's is on the left and Gabe's is on the right. Let me first tell you about Drew's. Drew wanted to make a big spider. He had several problems that he solved while he was counting the pipe cleaners, attaching the legs, and learning how to hold the eyes on until the glue would set up. Drew displayed persistence in problem solving. Sometimes in representation, it's not just about the model that the child is creating. It is about the process and learning some of those behaviors that are what we consider those learning and thinking behaviors, like persistence and problem solving. Those are actually elements of executive function. For Gabe's, we can see that Gabe saw a picture of a spider jumping onto a flower in a book. So that abdomen was very large and the head was very small, and it was intriguing to Gabe. He wanted to make a jumping spider. The spider was carrying babies on her back, and so Gabe wanted the legs to look like they were in the book, pushing in the jumping motion. And he also created the flower for the spider to jump on, which you can't see in this photo, but it is in the book. Here are more examples, and I just encourage you to read through figure 6-7 in the text. Different representations, all about spiders, but they are the children's interpretations of what they learned, and we're individualizing for each child's perspective, their interests, and for their thoughts on how to represent. In this particular document, you can see how the children talk about what they made. Maya says, I made it with paper and I paired it and I put it on this thing and I painted it red. And so here is the clay model of a spider that one of the children made. These are its pedipalps. So this is how the child drew what they did of their clay, Maggie's clay model. So we want to remember that we want to maximize intellectual growth in the renderings. What knowledge is used? So the content, right? The content of whatever project topic it is. What kind of thinking is required? So do they need to plan out the materials? Do they need to plan how they're going to put them together? Do they need to sketch it out first? Do they talk about that and discuss it? And then the product. How effective is the product as a representation of learning? So for very young children, we have to keep in mind it's important that we have their descriptions alongside it so that other adults aren't interpreting these things as blobs or misinterpretations, because that will just crush all of the deep hard work of our young children. So if we make a model of a spider out of clay, or other found material, we're pulling these content, process, and product together. So it's more effective because we are integrating more soundly and maximizing the intellectual growth in the renderings. So we can compare representations from two construction projects. On the left are houses created as a study on building houses. The teacher provided the templates. The children were told to cut, assemble, paste, and decorate them as they desired. How much knowledge was needed? Think about that. Not a lot to color, cut, and paste. So they're staying inside the lines, they're choosing different appropriate colors, not knowledge about constructing and representing houses. What kind of thinking was required? Well, following directions, using simple art material. How effective was the product and representation of learning? This one on the left doesn't really represent what children learned. It represents what they colored and cut. On the right is a child who is creating a roof to go on a house that they are building during a project on building. She observed roofers putting on a roof. She chose black plastic as a base and then went over and found shingles that were given to them by the roofer. She decided she would cut them into small pieces for their smaller model house. She began gluing them onto the black liner, which she will place on the roof of the house that her other friends are building. So now we want to think about process, content, and product. So how much knowledge was needed? Going back to the right-hand side now, well, the child is having knowledge of the different aspects of a real house. The thinking that was required is she had to plan, she had to evaluate the different kinds of real materials or the found materials in her classroom, and she also had to collaborate with her peers. And then the representation is that their final product is going to be much more realistic. So we can see the one on the right. Is that rendering builds the mind-brain capacity. And that's why it's so important as we learn to shift our understanding